All right, guys, if you would please grab out your worksheet on solving inequalities. Okay, so it's asking me to place two colored counter chips on a number line and place the yellow counters starting at a position of 2 and the green counter starting at a position of 4. Move the counters according to the direction of the chart below and observe which counter has a smaller value and which counter has a larger value. Okay, so we're just going to look at the numbers here and we're going to make a comparison. Okay, so we're going to use less than or greater than, and we're going to see which way our symbol is going to go to eat the bigger number. Okay, so to start off with 2 and 4, well, I need to open up to 4 because 4 is bigger than 2. Okay, it's going to tell me what to do to each of the numbers to the previous number. So for here, I'm going to add 2 to both of my previous values. So 2 plus 2 is 4. 4 plus 2 is 6. Well, I still have to open up this way because 6 is still bigger than 4. The next section is asking me to subtract 3 from both sides. So I'm going to look at my last value of 4 and 6, and I'm going to subtract 3 from both of them. So 4 minus 3 is 1, and 6 minus 3 is 3. Well, 3 is bigger than 1, so I need to open up in this direction. All right, so the next one, it's asking me to add -2 to both of my values. So I'm going to have 1 plus -2. Then I'm going to have 3 plus -2. So I'm going to do 1 minus 2, which is -1. 3 minus 2, which is 1. I'm still at 1 for both, but I'm at a -1 on the left side and a +1 on the right. So I need to open up to the right because +1 is bigger than -1. All right, I'm asked to subtract 4 from both sides. So I'm going to start with -1 and take 4 more away. Start with 1 and take 3 away. So -1 minus 4 is -5. And then 1 minus 3 is -2. Okay, so let's go over here and we're going to draw a number line here. And I'm going to have 0, -1, -2, -3, -4, and -5. Okay, if we had our counters right now, I would have my yellow counters right here at -5. I would have my red counters here at -2. And I want to know which one is the bigger number. When we are in the negatives, the smallest number, the number that's closest to 0, is bigger than the other number. So the counters that are closest to 0 are the ones sitting at -2, my red counters. Okay. All right, let's multiply both of these numbers by +2. So -5 times 2 is -10. -2 times 2 is -4. Okay, which number is closer to 0? And that's -4, so I need to still open up in this direction. Okay, I want you guys to note up until this point, we are still opening in the same direction. Now I'm going to subtract 2 from both of these numbers. So -10, I'm going 2 more into the negatives to have me at -12. I'm at -4 and I'm going 2 more into the negatives to give me -6. Now, which number is closer to 0? That is -6. So I still open up to the right. Then I'm asked to divide both of them by 4. So I have -12 divided by 4. Well, 12 divided by 4 is 3, and negative divided by a positive is a negative. Then I'm going to have -6 divided by 4. Oh, did I mess up something? Did I multiply everything correctly? Hang on, let me make sure I did my math right. Oh, it's right here, Miss Roberts. Totally messed up. 1 minus 4 is -3. There we go. -3. Then I should have -3 times 2, which is -6. Then -6 minus 2, which is -8. And I'm still opening up to the right, which there we go. Now we can do -8 divided by 4, because we should still be all in whole numbers. So -8 divided by 4 is -2. Well, -2 is still bigger than -3. Okay. Now I'm asked to take my number and I'm going to multiply it by -3. Well, negative times a negative is a positive, and 3 times 3 is 9. Negative 2 times a negative 3. Negative times a negative is a positive, and 2 times 3 is 6. Well, wait a minute. Now my left side, now my yellow is bigger than my red. All right, I'm going to star this right here because I noticed something. Okay, let's see what happens. And so 9 minus 3, I'm going to subtract 3 on both sides. I get 6. 6 minus 3, I get 3. All right, well, 6 is still bigger than 3. Now I'm going to divide by negative 3. So 6 divided by negative 3. Well, positive divided by negative is a negative. 6 divided by 3 is 2. Now I have 3 divided by negative 3, which we know is going to be a negative. And 3 divided by 3 is 1. Well, wait, negative 1 now is bigger than negative 2. So now my alligator's going the opposite way. Okay, so wait a minute. I'm flipping here. Now my alligator changed positions. Now I'm going to have negative 2, and I'm going to divide by 0.5. Well, negative divided by a positive is a negative, and it is negative 4. Negative 1 divided by 0.5. Positive divided by negative. Negative divided by a positive is a negative, and I'm at negative 2. Okay, so negative 2 is still bigger. And then the last one is multiplied by negative 0.5. So I have negative 4 times negative 0.5, which this ends up being 2. Then negative 2 times negative 0.5, which this ends up being 1. Now wait, 2 is now bigger than 1. So my yellow is in the lead. Okay, so it's saying which math operations caused the cubes to switch orders on the number line. So we noticed that when we multiplied by negative 3, my sign flipped and now I'm bigger over here. Then when I divided by negative 3, my sign flipped again. And then when I multiplied by negative 0.5, my sign flipped again. So the cubes switched their order only when multiplied or divided by a negative value. Only when they were multiplied or divided by a negative value did they flip their sign. Okay, so let's put this to test here. Letter B, solve the following inequalities and answer the questions that follow. Okay, so we learned the other day that solving inequalities is the same thing as solving an equation. I'm still going to draw my line straight down, but this time I'm going to bring my symbol straight down. So to get x by itself, I need to divide by 2 and divide by 2. Now I'm left with x is less than negative divided by positive is a negative, and 4 divided by 2 is 2. So it's asking me, was there a need to switch the inequality symbol? Why and why not? And the answer is is no. We did not divide by a negative. Okay? Because if we look back on the front side, okay, when I divided by a positive number, I didn't flip my sign. My sign stayed the same all the way throughout. Until I got all the way down to here to divide by negative 3, did I flip my sign? Because originally I was going from here, and then I flipped it backwards. So I noticed that every time I multiply or divide by a negative number, so multiply or divide, I need to flip the sign that I have. Okay? Let's look at number 2, negative 2x minus 4. Well, in order to get x by itself, I need to divide by negative 2 on both sides. And I'm going to have x, and wait, I'm dividing by a negative, which we saw in the front means I have to flip my sign. Okay? Negative 4 divided by negative 2 is a positive, and 4 divided by 2 is 2. So was there a need to switch the inequality symbol? And yes. Why? Because we divided by a negative 2. Okay, we divided by a negative 2. All right, let's check number 3. Divide by 2 on both sides. Well, x is going to be less than, because I'm dividing by a positive. 4 divided by 2 is 2. Was there a need to switch the inequality symbol? No. And then let's try this one. Okay, this one looks a little bit harder. It's a 2-step question. So I'm going to add 1 to both sides. Left with negative 1/2 x less than, well, 7 plus 1 is 8. Okay, I need to divide by negative 1/2. Divide by negative 1/2. Well, look, I'm dividing by a negative, so I need to flip my sign. And then 8 divided by 1/2, or negative, is the same thing as 8 over 1 times negative 2 over 1, which is what? Negative 16 over 1, which is negative 16. Was there a need to switch the inequality symbol? And the answer is yes, because we divided by a negative. Okay. All right. So if the variable is a blank or blank by a blank number, then I must blank the inequality symbol for the statement to be true. All right. So if the variable is multiplied or divided, by a negative number, then I must flip the inequality symbol for the statement to be true. All right, let's try some extra practice here. Okay, let's take a look at number 1. Let's try number 1. So the first thing I see is I'm adding 5, so I need to subtract 5 on both sides. 5 minus 5 is 0. I'm left with 2x is less than, well, negative 17. Now I'm going to go 5 more into it. So 7 plus 5 is 12. Carry the 1 and 2, and I'm still at a negative. I need to divide by 2. Now, am I dividing by a positive or a negative number? Well, right now it's positive, so I do not flip my sign. So my sign stays the same. And a negative divided by a positive is a negative, and 22 divided by 2 is 11. All right, let's try, I like this one. Let's try number 3. Okay, this time I'm off to the different side. So right now I'm adding 1 to this side, so I need to take away 1 on both sides. I'm left with negative 8x, so less than or equal to negative 8x. 197 minus 1 is 96. To get x by itself, I need to divide by negative 8. And I'm going to divide by negative 8 on both sides. Now pay attention, I'm dividing by a negative, so I'm going to flip my sign. Okay, and well, 96 divided by 8 is 12. And this is a negative 12. Okay. All right. And then I want to do one more with you, number 6. Let's try number 6 together. The first thing I need to do is subtract 7 from both sides because I'm adding 7 to both sides. I'm left with a negative x is greater than or equal to, well, 18 minus 7 is 11. And I want you guys to notice something. Every time we give an answer of whether it's x equals 2 or x inequality a number, the x is always positive. So what number is usually in front of this x that's invisible that we never write? Well, the number in front is 1. Okay, so I need to divide by negative 1 on both sides to get this x from a negative value to a positive value. And when I divide by negative 1, I need to flip my inequality opposite, and then I'm going to have 11 divided by negative 1 is negative 11. All right. I want you guys to go in and I want you guys to try number 2, 4, and number 5. If you guys have any questions, please let us